So this is an interview question that I've gotten before in a real interview. What is the difference between classes and interfaces? Now, if you've received this kind of question during an interview, you should probably talk all about Java and how they have subclasses and inheritance and all those Java-specific properties. But this presentation is not about Java. Instead, we're going to be taking a very deep dive at what these classes and interfaces actually mean and how they are related to each other, and understand the theory behind them. So to guide us through this, we're going to be looking at this definition of a polygon. So a polygon class is anything that implements the three methods area, perimeter, and number of sides. So let's write them down in a table where each row represents our different methods. We can now instantiate an equilateral triangle of a polygon by saying that an equilateral triangle is a instantiation of the class by these three different implementations of the methods. We can similarly add new instantiations like this right triangle, and we can also add a square. So we've created this table that represents what it means to be a polygon. So we would like to tell the computer that a polygon is defined as this table. But the computer doesn't understand what a table is. We need to explain it more directly to the computer. So we can take this table and break it down via each column. So let's zoom into the square column. And we see that the square contains three different functions, one for the area, one for the perimeter, and one for the number of sides. And for each one of these functions, we can refer to that specific function via a projection from this record type. So we, as long as we have these three functions put together, we can grab each one of these functions by referring to it via the name of the function. So this is only for the squares. We can build this up into the polygon class by creating one function that returns the tuple of the area, perimeter, and sides, the tuple or record. And so this one function will have three different kinds of inputs. So you're going to be casing on whether you receive an equilateral triangle, a right triangle, or a square triangle. And the output is going to be the record of that particular class. So the particular instantiations of the methods area, perimeter, and sides for that class. So that is one approach. Another approach is that we can read this table through each row. So let's zoom into the area row. So the area row is a function, it's a method that cases on whether you have a triangle or a square, and provides a specific function for each one of those. So the input is going to be a case analysis on all these three different kinds of shapes, and the output is going to be the specific function that gives you the area based on what the input is. Meanwhile, the polygon is going to be the product or the record that holds an area function and a perimeter function and a sides function. So now you can project out of polygon for the area, and it gives you this case analysis function. To break it down, classes are columns of fixed rows and interfaces are rows of fixed columns. So this means that the only real difference between these two is the way we interpret the table, whether we interpret it via columns or via rows. This also means that if we want to instantiate a new class, we would define a new function for each one of the methods to create a new instance of the class. But if we want to create a new interface, a new method, we would need to define it for each one of the different instances, each class instance. It basically means that we are either adding in a new column and defining each row, or adding in a new row and defining each column. Because this is the same chart, it sort of means that the column method and the row method are both valid ways of interpreting the same chart, so they have to be related to each other or isomorphic. You can interpret the column method as being one function that has 3 inputs, and each one of these inputs is going to case analyze and give you a tuple of 3 results. So if you write it out with exponentiation, you can do distribution over this exponents. So this is just the distributive law. And you get 3 separate functions, each that are casing on these 3 different inputs, but instead of providing 3 results, you provide 1 result. It's just a rearrangement of whether you're looking at it from column first or row first. Additionally, there's this topic called row polymorphism, but it's also sort of called duck typing, and that comes from the phrase, if you walk like a duck and you quack like a duck, then it's a duck. So as long as you implement the 2 methods, walk and quack, that's all we really care about. You are a duck. So a human that can have a whole bunch of these extra methods in there, like walk, talk, quack, eat, sleep, and work, as long as you implement walk and quack, a human is a duck. This is what is also called subclassing in Java. But this allows us a very powerful method for designing more specific objects while referring to only a more general property, a weaker property when we actually use the object. So going back to the interview question of what is the difference between classes and interfaces, the real difference is really just how you look at it at the same table, whether you look at it from column first or row first.